Hi, my name is Arthur de Oliveira. I am a master's student at the University of São Paulo in Brazil. My supervisor is Dr. Gastão Eduardo Henrique Rojas, and my talk is about the magmatic interaction between mafic-ultramafic rocks and intruding syenites at the São Sebastião Island, Brazil. These are some selected results of my ongoing master dissertation. For a little bit of context, there are some alkaline occurrences on the southeastern Brazilian coast that have cyanides intruding mafic-ultramafic alkaline complex. For example, the alkaline rocks at the Monte de Trigo Island and Morro de São João. Here we have the enclaves of the mafic rocks that were brecciated by the cyanides. Timich and collaborators at 2019, they described an outcrop at the north of the São Sebastião Island where the cyanide not only intruded the mafic rocks, but they also mixed with them. Here is the outcrop location. It's a headland west of the Jabaquara Beach that was divided in 6 sectors on the basis of accessibility and some geological features. The main feature of the sectors of this outcrop is mafic-ultramafic enclaves that are brecciated by the cyanide rocks. Here we have an intrusion in sector 2 of the cyanides that result in this enclave swarm-like structure that results in this sharp and angular enclaves. This is a view from the sea of the outcrop. In the northern sectors, we have a large melacyanite enclave, about 45-meter wide, that is mesocratic, and it has rare gabbro enclaves. They are corroded, small, and we can see that the minerals of these enclaves are dissipated throughout the surrounding host rocks. So one of the first problems we try to answer with our research is if the melacyanite really is a hybrid rock and how it was formed. In the petrography, we can see some disequilibrium textures between the alkali feldspars and the plagioclase. For example, here, and these alkali feldspars, they are derived from the alkali feldspar syenites, and this plagioclase and these mafic minerals are derived from the mafic enclaves. The plagioclase, they are recrystallized with rare polysyntactic twinning visible. There's also mafic clots with abundant apatite crystals. Those are very similar texturally to those found in the mafic enclaves. So the melacyanite appears to have mechanically assimilated the minerals based on the field evidence and this petrographic evidence. But is it only a mechanical assimilation? We see that there is some recrystallization. So can we assume that was mechanical chemical mixing of these minerals? Based on the mineral chemistry, you can see the clinopyroxene and melacyanides here in this light green. They have a trend of cyanide and the mafic rocks. We can see they are similar to a few of the mafic rocks, but they are trending towards the cyanide compositions, syenitic compositions. Amphiboles, they are related to these mafic clusters, but they are trending towards the syenitic compositions. And the feldspars, here we have the alkali feldspar. The melacyanites, they have a higher calcium anorthite component when related to their cyanide counterparts, whereas the plagioclase, they have a higher albitic composition compared to the mafic plagioclase. So we can say that the felsic and mafic derived minerals, they have undergone a partial mixing. We have the mechanical mixing and also a chemical mixing. So there were at least 2 pulses of syenitic magma based on the field and petrographic evidence. We can say that a first pulse was the one that mixed with a late-stage crystallization of mafic-ultramafic magma that generated the malacyanite, and a second one intruded and brecciated desolidify malacyanite and mafic rocks. So we saw that malacyanites have a chemical mixing component. Did the enclave experience some sort of chemical mixing, some sort of reaction with the surrounding host rock? We have here a contact of the gabbro with the syenite rocks. We can see that the pinkish claniperoxene from the enclave is being transformed into a green claniperoxene from the syenite. We also have a crystallization of the mafic and the plagioclase of the enclave, which is shown here by this finer texture. We also have a formation of biotite replacing amphibole here and here. Here is some X-ray compositional maps made by electron microprobe analyzer. Here we have a potassium map, and we can see the mafic enclave here and the alkali feldspar cyanides. And this is a biotite rind that's formed by the expanse of the amphibole here, demonstrated by this pink hue. And the plagioclase, we can see an anortic core in the gabbro, which turns into a more sodium albite plagioclase here in the contact with the alkali feldspar cyanide. So we can see there's at least two zones based on the petrographic and the X-ray maps. We have the mesocratic halo in the alkali feldspar cyanide, which is especially characterized by a large amount of clinoperoxine, that is assimilation of the mafic minerals from the enclave. And in the enclave, we have a biotite-rich rind, which is which has a composition of biotite and sodium plagioclase, which is a reaction of the potassium, possibly sodium-rich fluids from the host rocks that are reacting with the enclave minerals. The presence of fluids are corroborated by mineralitic cavities that are found throughout the outcrop. Here we have filled with quartz, biotite, plagioclase, and carbonates. A few key points that we can take from this talk is that the Sahara cyanide has had at least two cyanitic pulses, one even mixed with a malacyanide, which in stark contrast with other alkaline intrusions, nearby intrusions, did not form hybridization with the enclaves, which show a larger temporal gap between the mafic and the cyanide magmatism. This malacyanide was formed not only by mechanical dispersion of the mafic-ultramafic minerals into the cyanide, but also a recalibration of those minerals. And the later pulse, they assimilated minerals from the mafic enclaves. The plagioclase from the gabbros was recrystallized into a sodium-rich plagioclase, both in the malacyanide and the contact of the mafic enclaves, and the host rock fluids reacted with the enclave amphibole to form biotite rinds. So that's it. Thank you for listening.